Example 1b. Again, we want to find the enclosed area between two curves and two limits that are now on the y-axis. Okay, so the area lies between two limits on the y-axis. So that's the trigger as to what formula we're going to use. So we're going to use the formula A equals, area equals, we're integrating between A and B. Now remember, A and B are now the limits that are on the y-axis. So because the limits are on the y-axis, then it's going to be the curve to the immediate right of the area. Subtract the curve that's to the immediate left of the area. And we're now going to be integrating with respect to y. Because the limits are y values, that means we're integrating with respect to y. Now, the next thing we have to do is get the curve that's on the right and the curve that's on the left in terms of y. So that means we've got to make x the subject of both of these. Let's look at the curve that's to the immediate right of the area. So to the immediate right of the area here is the line y, the y-axis. Now the equation of the y-axis is x equals 0. So x equals 0. So we've made x the subject of the curve, and again I use curve loosely because a curve can be, in this case, a vertical line or just a curve. So the curve to the right of the area is x equals 0. X is the subject. We've also got to make x the subject of the curve that's to the left of the area. So we're talking about this curve here. Now that curve at the minute has the equation y equals x squared, but we have to make x the subject. So we start with y equals x squared. To make x the subject, we have to get rid of the power of 2, so we're going to take plus or minus the square root of the other side. Now we have to make the correct choice here. Are we going to use x equals positive root y or negative root y? Well, that depends where this curve is with respect to the y-axis. This curve here, that's to the left of the area, is to the left of the y-axis, so we use the negative version. So we're going to use negative root y equals x. That's because the curve is to the left of the y-axis. So we're now good to go and work out this area. We know everything, so that means area A is equal to, so the integral, limits are 1 and 4, so bottom limit 1, bigger limit 4. The curve on the right is just x equals 0, so we're just subbing in 0. And then we're subtracting the curve on the left, which is negative root y. And then we are integrating with respect to y. So tidy it up, so multiplying this second bracket by the minus, minus times minus is plus. So we now have the integral between 1 and 4 of positive root y. Now positive root y is just y to the power of a half dy. So we're now ready to integrate. So because there's limits, we also put square brackets down. We add 1 to the power and then divide by the new power. So we're going to get y to the power of 1.5. And then we divide by 1.5. And then we add our constant. And then we put our limits outside. Again, dividing by 3 over 2 is the same as multiplying by 2/3. Okay, we're going to break up the square bracket into 2 separate square brackets with a minus between them. We're going to chuck the top limit into the integrated expression in the first square bracket. So we're going to have 2/3 times 4 to the power 3 over 2 plus c. And then in the second square bracket, we're going to chuck the bottom limit into the integrated expression. So we've got 2/3 times 1 to the power 3 over 2 plus c. So let's tidy up. Okay, so 4 to the power 3 over 2, that means you're taking the positive square root of 4 here, which is 2, and then you're going to cube it, so that's going to give you 8, and then you're multiplying by 2/3, so that's going to give you 16 over 3 plus c. And then we're subtracting, remember 1 to the power of anything is 1, so positive square root of 1 is just 1, and then cube 1 is still 1, so you're just going to be left with 2/3 here plus c. So tidy it up, we're going to be left with 16 over 3. The constants cancel, so we're just left with minus 2/3. So that's going to leave us with 14 over 3, or as a mixed fraction, that's going to be 4 and 2/3, and it's going to be units squared. Okay, so again, we've now found the area enclosed by two curves between two limits on the y-axis. So that's the trigger in these questions. The limits are on the y-axis, so this is the new formula we use. We don't use top minus bottom anymore. The limits are now y limits. It's now the curve that's on the right, immediately to the right of the area, subtract the curve immediately to the left of the area, and we're integrating with respect to y. So that means the curve on the right and the curve on the left, you have to make x the subject of both of them, and you're subbing in essentially y terms in here.